Hi there, we're going to look today at exercise 22D. It's in two parts. We're looking initially at trying just to deal with the problem you get with forces and moments when they're not necessarily at a perpendicular angle. So you may recall that this comes about when you find moments. Before we go on to that, let's just do the starter. The starter is just, I want you to try to find for me, using SOHCAHTOA, what the value of x and y is in both examples. So pause the video and see if you can find the value of x and y in both examples. Okay, hopefully you've done that. So if I was doing this, I would have said, well, cos of the angle is the adjacent x over the hypotenuse. I would have moved the 30 over, I would have ended up with x equals 30 cos 35. And you get a similar thing if you do y, you end up with sine 35 is y over 30, or rearrange again, you get 30 sine 35. And when you write them like that, you think, well, actually they're quite similar, and that's because they are. I will get the answers up in a bit so you can check your answers. The thing I notice over here then is this is essentially the same question. So this answer is 45, and because I want to go across, I think I'm going to use cos, so it's 45 cos 28. And y is 45, because it's going up and down, I use sine. Now it's not necessarily a great rule that, let's just get the answers that you should have got. What I basically said, if you're trying to go across, you use cos, and if you go sine, it's up. It's not a great rule, because really what you're saying is, if you want the part of the either the horizontal or the vertical forces, which are kind of if you want the one next to the angle, adjacent to the angle, we're going to use cos. But if you want the one that goes away from the adjacent side, and if like goes up perpendicular to it, perhaps this should say the perpendicular force. That would be a better description, I think. So if you want the perpendicular force, you're going to use sine. So that might be a good way to remember it. So let's just go back to basics. The moment here, you'll notice first of all it's forcing it round that way, so it's a clockwise one. And the moment is it's just the distance, the force and the distance, and because it's a perpendicular force, I can just go 30 times 2 F times D, if you like, and that's 60 Newton meters in a clockwise direction. Well, this one I think goes that way round, so this is anti-clockwise. And how big is it? Well, it's a very easy sum, isn't it? It's 45 times 1. And the critical thing is, it is 45, it is 30, because these forces are perpendicular. So this should be 45, and there it is. There's the answers. The obvious question then to ask is, what do you do if it's not perpendicular? And so this question here, the one thing I want you to do first of all, I want you to say, well, perpendicular force. What is the perpendicular force? And you can see essentially, you imagine this is my last question. This is my distance away from some point I'm taking. And I really would have liked it to have gone straight up my force. That's the force I want. That's the F, perpendicular force. But it's not. What do I do? Well, it's called resolve it. And when I resolve this force, I use the rule that I just saw. And because it's I don't want the force which is adjacent to it. I want the force which is perpendicular to it. So that is going to be the 25. Sine, he said cos, sine 40. That's the perpendicular force. And therefore, to get the moment, it's going to be 25 sine 40. What was that? Let's just do that. 25 times sine 40 is 16.1-ish. Now, being a bit more accurate than 16.1, I'll do that 16.1 now, and I'll times by the 3.2. Because I've got the perpendicular force. So it times that answer by 3.2, and without any rounding, I get 51.4 Newton meters. Hopefully that's what you've got now. That's the force I would have had if I resolved it, so you can see that would send it round that way. It's a clockwise answer. What's this one do? Well, first of all, I want you to realise that this is essentially my distance, and this is the force that I want. So what that tells me is I've got to get, say, that force there, or that angle there, sorry. If I can get that angle there, then I'll know what I have to resolve it through. So this is 30. I'm just trying to do some, now this is almost GCSE angles. So that's 30. Corresponding angle tells me that's 30. And by definition, this must be 60 because these are a right angle between them. So now I know it's 60, I'm going to use it. So my perpendicular force this time is, now remember what I said, if you want the adjacent force you use cos, but if you want the perpendicular force you use sine. So I'm going to use, I've got the 60, I've got the right angle there, so I'm going to use 35 sine 60. And again, let's type that into my calculator. 35 times sine 60 is 30.3-ish. And again, now I've got my perpendicular force, it's relatively easy to find my moment because it's at 30.3 times by the 1.2. So times that answer on my screen by 1.2 and I get 36.4 Newton meters. Let's see if they're the right answers. Yes, they are. Oh, I didn't mention whether this was clockwise. Yes, it's going around that way, isn't it? You can see that's an anti-clockwise answer. So okay, we've got so far. So what we're going to do now, we've got a uniform rod of length 2L. Now they do that deliberately because then there's an L and an L kind of halfway. And alright, it's because it's uniform. We talked about this last time. When it's uniform, its weight, which they tell us is 50 newtons, acts from the centre. So that's 50 newtons acting from there. And it says two of the strings, right, there's a total of 4 strings, or I can see them here. That's I'll call this one T1, I'll call this one T2. We've got this one here which is T3, and this one here which is T4. And my job is to find all those tensions. Now actually one of them I just noticed is very easy, because you always know that forces up equals forces down. I think I've shown this on the previous slide. So forces up 20 plus T3 must equal that 50. So 20 plus T3 equals 50, and by definition therefore T3 is 30 newtons. So one of them done. Nice, easy. Now forces left equals forces right as well, but on that all it tells me is that T1 equals T4. If I get one of them, I get both of them effectively. So I'll put that to one side. I think now I've got to go and take some moments. So you can use basically a combination of these two techniques. Forces up equals forces down, forces left equals forces right, just a basic trick like that. But then moments are a bit trickier. I'm going to take moments from here, and let's see if that's a good place. The only reason, well, I'm not sure if I should do it from there or not, I don't know. So I'm doing it from there. I'll call this A, I'll call this B. The lovely thing about finding, if you do know that you've picked the point where this force is acting, then you can ignore the forces acting from there. So I'm ignoring T1 and T2 now. So what am I doing? I'm going to say, take moments from A, I've shown you that notation before, and I need this force. That's the force I need. That's the force which is perpendicular to that length. So if I'm going to get that force here, the way I'm going to do it is I need to get the angle here. This is the angle which is kind of going in the same, attached to the triangle from the force here. I've got to sort of resolve that in this direction. Again, it's not the adjacent force I want, it's the perpendicular force. So I reckon that force there is the 50 sine whatever this angle is here that I've coloured in, and you can see this is a little right angle triangle. This is 60 degrees, so 50 sine 60. So right then, so I've got this, F equals that. Let's type that into my calculator. 50 times sine 60. I've got 43.30. I'll give it 1 dp extra because I'll need that in a bit. What else do I need? Well, I'll need this force here, and this is my perpendicular force again. Again, this is 30 degrees, so this up here must be 30, which means this is 60. And of course, I know my T3 is, was it 30 newtons? That's what I found over here. So I need to resolve it through the 60 degrees. So I reckon this particular little force is the 30 sine 60. You just got to get it right. This T4, again, now I've got a 30 degree angle. So I think this one is, whatever T4 is, I'm going to resolve it in this direction to get the F that I want. And it's going to be the T4 sine 30. So using all those three forces, let's just have a look. Moments from A, so it's the force times the distance. So it's the 43.30 times the length. So that's that force ticked off. Now that one is a clockwise force. And I actually think this one's a clockwise force as well. So I'm going to add on to it the T4 sine 30. And I think that's got to be equal to this one, because this one will drag it round this way. This is the anti-clockwise force. So it's equal to, I forgot to times that force by the distance it is away. And it's all 2L away this time. So that has got to be equal to 2L, which is the distance again, times by this force. So that is the 30 sine 60. So let's just do a bit of work here. Well, first of all, I notice there's L's everywhere. So I can divide everything by L, and that makes it a lot easier. I've got a 2 here and a 2 here. I'll just bear that in mind. So I get 43.30 plus, now sine 30 times 2 is 1, I think. So sine 30, close bracket, times 2 is 1. So effectively that cancels with that. And I've just got plus T4. And that equals 2 times the 30 times sine 60. I get 51.96. So presumably T4 becomes 51.96 minus the 43.3, and that is 8.66 newtons. So that's my T4. I've already said that T1 is equal to it. So T1 I think is also equal to 8.66 newtons. Have I got them all now? I've got T1, I've got T4, I already knew T3. So let's see if I've got them right. 8.66 for the horizontal tensions, yes. And I got 30 for the vertical tension. So that's all worked out nicely. Now, I'm going to come back to these in PowerPoint 2, and after the second PowerPoint, then I'll set you to work on the the last exercise in the textbook, last proper exercise in the textbook of exercise 22D, I think it is.